Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called binary search tree iterator. We're going to implement the binary search tree iterator class that represents an iterator over the inOrder traversal of a binary search tree. So this initializes an object of the BST iterator class, and the root of the binary search tree is given as part of the constructor, as shown here. The pointer should be initialized to a non-existent number smaller than any element in the BST. And there's a function called hasNext, which returns true if there exists a number in the traversal to the right of the pointer. Otherwise, return false. And next function will return an integer that moves the pointer to the right, then returns the number at that pointer. Okay. And we're going to initialize the pointer to a non-existent smaller number. The first call to next will return the smallest element in the BST. Okay, so basically we're going to do an inOrder traversal, and we will check if there's a next element. If there's a next element, we'll return its value. We'll first make a judgment whether we have a next, and then when we call this, we can return its value. Okay, so basically here's a BST, and the inOrder traversal gives us 3, 7, 9, 15, 20. Okay, so we should have it right here. And next 7, 3. Okay. Next will be the first element here. That will be 3. That's right. Next 7, right? hasNext, yes. So true. Next 9. hasNext, true. Next 15. hasNext, true. Next 20. hasNext, false. Okay, so this is the last element of the BST. Okay, so this is generally pretty simple. So basically we're just doing a inOrder traversal. Okay, so for this BST iterator, if we have a list of integer with all the nodes, all the numbers in the nodes in sorted order, and we're going to initialize an index that is non-existent. Okay, so let me write it down here. And for the constructor, this root will be, so let's just, this sorted will be a new ArrayList. And we have the root, so we have to run a function, sort of function, to do the inOrder traversal and add all the values in the BST into our sorted ArrayList. Okay, so this dot root, we can call a function called flatten root. We're gonna flatten this tree to an array and put it into an ArrayList. Okay, an index will be initialized to a non-existent number and less than 0. So I will set it to -1. Okay, so now I just have to write down the function flatten, which takes in a tree node root. So if root equals to null, we're going to return. And since it's inOrder traversal, we are going to call this function on the left child, and then we will add the current value of the root into our sorted ArrayList, and then we call the function to the right subtree. Okay, so that's basically how it goes. And let's see the two main functions. This one is next, and so next we're going to return the next element. Okay, so we have to get it from the sorted array. Get, now we have an index, but we have to increment it before we can return. Okay, so that's how we write this function. And for hasNext, basically we're going to return the current index plus 1 if it's within the range of the sorted array. It should be all right. Okay, so that should do. Yeah, that passes the test cases. So let's analyze the complexities. So for time, since we're doing the flatten function, it should be on. And for space, since we're having this sorted array list, it should also be on, because whatever it is, we're going to store all the elements in this BST. Okay, so let's submit it. Yeah, perfect. It passes the test cases. Thank you so much for watching. If you liked the video, be sure to like the video and subscribe to my channel. I'll see you in our next video.